Does space have sound? The short answer is no, and also sort of. That irritating little wrinkle is exactly the kind of thing physics likes to do. It takes a question that seems simple, waits for you to answer too quickly, and then quietly rearranges the furniture. When most people ask whether space has sound, they mean outer space. The big black stretch between planets and stars. The place where spaceships float, astronauts drift, and science fiction directors feel the urge to add ominous humming noises because silence makes audiences nervous. In that setting, the usual answer is no. Space, in the ordinary sense, does not carry sound the way air on Earth does. And the reason is straightforward. Sound is vibration moving through matter. A thing shakes. It is not some free-floating essence of noise that can simply wander wherever it pleases. Sound is vibration moving through matter. A thing shakes. That shaking jostles nearby particles. Those particles jostle more particles. A pressure wave travels through a medium. Air can carry it. Water can carry it. Steel can carry it. Your apartment wall can carry it, which is why your neighbor's taste in music becomes your problem at midnight. But empty space is mostly empty. And mostly empty here is doing heroic labor. Radiation, and all manner of cosmic mischief. There is dust. There are solar winds, magnetic fields, radiation, and all manner of cosmic mischief. Yet compared with the dense, busy atmosphere around you right now, outer space is so thin that ordinary sound waves do not propagate through it in the way they do on Earth. There are not enough particles packed close enough together to pass those pressure vibrations along in the familiar way. So if you were floating outside a spacecraft and an explosion happened some distance away, you would not hear the booming fireball that movies love to give you. Quite literally, you would see it. That is one of the strange things about reality. It is often less theatrical than fiction and more severe. A great detonation in space would produce light, heat, radiation, debris, and shock within whatever material was actually present. Yet if there were no medium between you and the event, there would be no sound traveling through the vacuum to your ears. The universe, in that respect, is stingy with acoustics. This is why old science fiction often gets space wrong. You hear the roar of engines in vacuum. You hear ships scream past each other. You hear explosions thud like naval artillery. You hear laser blasts that somehow behave like glowing bullets with an opinion. It is all very enjoyable. It is also nonsense. At least if we are talking about sound traveling through vacuum, the way sound moves through air. To be fair, films are not physics lectures. Absolute realism would sound very odd to viewers, because most space battles would be eerily silent from an outside perspective. Flashes of light from a distant event over a dark, silent moonscape. There would be visual chaos and acoustic emptiness. There would be visual chaos and acoustic emptiness. That is more accurate. It is also less satisfying to people who paid for popcorn, and would like their orbital warfare to come with bass. Yet compared with the dense, busy atmosphere around you right now, wind howls, water rushes, trees creak, engines rumble, doors slam, thunder rolls. Wind howls, water rushes, trees creak, engines rumble, doors slam, thunder rolls. Even quiet places are full of little sounds. Space strips that away. A collision can happen in perfect silence. A sunrise over Earth from orbit can occur without the faintest stirring of air. An astronaut can look upon the whole curve of the planet, while hearing only the sounds inside the suit and the breathing near his own face. That is a very different kind of majesty. Now, this is where people sometimes get confused, because they hear scientists talk about sounds from space. NASA has released eerie clips called the sounds of black holes, the sounds of planets, the sounds of the sun, and the sounds of the early universe. So what gives? Were the scientists lying, or have they simply joined the rest of us in making peace with melodrama? Neither, really. What is happening in those cases is more subtle. Sometimes scientists are converting data into audio so humans can perceive patterns that would otherwise be invisible. A telescope detects X-rays, radio waves, plasma oscillations, or other signals. Those signals are translated into sound frequencies we can hear. The resulting audio is real in the sense that it is based on real data. The resulting audio is real in the sense that it is based on real data. Yet it is not the same thing as a pressure wave traveling through vacuum and into a human ear. Simply put, it is a translation. A sonified black hole is a bit like turning a spreadsheet into music. The underlying information is genuine. The sound you hear is a crafted representation that makes the structure legible to human senses. There is nothing fraudulent about that. It is useful. It can even be beautiful. Yet it is not the same as saying there was literal audible noise in vacuum, waiting for someone to press play. There is another wrinkle though, and this is where the answer becomes no, and also sort of. Space is not all vacuum. Certain regions of the cosmos contain enough matter for pressure waves to exist. Gas clouds, plasma environments, stellar interiors, planetary atmospheres, and clusters of galaxies can support wave behavior that is analogous to sound. In those places, there can be actual pressure oscillations moving through material. The famous example people like to mention is the Perseus galaxy cluster, where astronomers described pressure waves in the hot gas surrounding a supermassive black hole. Those waves were far too low in frequency for human ears, and far too alien in medium for direct human listening. But the basic principle was real. Matter was there. Pressure waves moved through it. That is closer to sound in the physical sense. So the better answer is this. Vacuum itself does not carry sound. The same goes for planets with atmospheres. And space contains both vacuum and matter, distributed in wildly uneven ways. That distinction matters because people often treat space as one uniform thing, as though everything beyond the atmosphere were the same black emptiness. It is not. Some regions are extremely sparse. Some are filled with plasma. Some have dust and gas. Some are inside atmospheres. Some are inside stars, which are very much not silent in the relevant physical sense. A star is less a quiet lamp than a boiling riot under tyrannical gravity. Take the sun. Can sound exist in the sun? Yes, because the sun is made of dense, hot plasma, and pressure waves can move through it. Scientists study oscillations in the sun to learn about its internal structure, a field called helioseismology. In plain English, they study the sun by analyzing how it rings and ripples internally. The sun is not a mute ball of fire. It is more like a vast, resonant furnace whose internal motions can be measured. We do not hear it directly with our ears from Earth, because the vacuum between us and the sun does not carry those waves to us. Still, the waves exist inside the sun. The same goes for planets with atmospheres. Mars has an atmosphere, thin though it is. That means sound can travel there. In fact, NASA's Perseverance rover recorded actual Martian sounds. Wind, mechanical noises, the little rasp of movement in a world that feels almost empty. The atmosphere is much thinner than Earth's, so sound behaves differently. It is weaker, stranger, and more selective in how it travels. Yet it exists. Mars can be noisy enough to record, though it remains a quieter customer than Earth. So when people say there is no sound in space, they usually mean there is no sound in vacuum. That is true. But once you start talking about atmospheres, gas clouds, plasmas, spacecraft interiors, suits, or clustered matter, the story becomes more complicated. Spacecraft are a good example. In the movies, we often hear the exterior roar of a spacecraft engine. Wrong. Yet inside the craft, things can be loud. Fans whir, pumps hum. Structure-borne vibrations pass through metal. Equipment clicks and rattles. The International Space Station has often described it as surprisingly noisy, because the station is full of machinery needed to keep people alive. So a person living in orbit may be surrounded by space and hear plenty of sound, though that sound is traveling through air inside the station or through the structure itself, not through the vacuum outside. The suit matters too. If an astronaut strikes something with a tool while outside on a spacewalk, vibrations can travel through the suit or through contact points and be perceived. So there are ways for a person in space to experience sound-like effects or vibration. The silence applies to the vacuum around them, not to every material connection they carry with them. This is why the question has charm. It looks like a child's question, but it opens into several layers of physics. What is sound? What counts as a medium? What does space refer to? Vacuum? Plasma? Atmosphere? A spacecraft cabin? The inside of a star? It turns out that even a simple question can become a hallway with many doors if you push on it long enough. There's also a deeper reason people care about this question. We are creatures of sound. We orient by it, we react to it. A crack behind us turns the spine to ice before the mind catches up. Music stirs memory. Voices steady us. Noise tells us where we are. Silence can feel holy, peaceful, lonely, or menacing, depending on the setting. So when we ask whether space has sound, we are really asking something larger. We are asking whether the universe beyond Earth feels familiar to beings like us. And in one important sense, it does not. Space is not built to flatter human senses. It is dark, cold, vast, violent, and mostly indifferent to the sensory habits of a primate that evolved in forests and grasslands. You cannot breathe there. You cannot hear across the void. Distance becomes absurd. Motion becomes hard to judge. Heat and cold behave in ways your intuition does not handle gracefully. It is a place where many of the little assumptions that guide daily life quietly stop working. That is part of its greatness. The silence of space is not a bug in the universe. It is a reminder that Earth is a special sort of place. Here, the air carries voices and music and thunder. Here, leaves rustle and fires crackle, and rain taps at the window. Here, sound fills the world because the world is thick with the material needed to bear it, and reveals a harsher stage where many of our ordinary experiences no longer come along for the ride. From a strict physical standpoint, silence is more accurate for exterior shots in vacuum, which brings us back to science fiction for a moment. Should films make space silent? Sometimes yes, sometimes no. From a strict physical standpoint, silence is more accurate for exterior shots in vacuum. From an artistic standpoint, sound can help tell the story. A film is not a lab report. Still, the best directors often do something clever. They use muffled sounds, internal vibrations, or selective silence to suggest the strangeness of the setting, without turning the whole experience into an acoustic desert. When done well, it feels uncanny. You sense that something is wrong by Earth standards, which, of course, is exactly right. Reality in space is stranger than the old Pew Pew soundtrack. So, does space have sound? If by space you mean empty vacuum, no. If by space you mean the broader cosmos, then parts of it can support pressure waves, because parts of it contain matter. If by sounds of space you mean the eerie audio clips scientists release, those are often translations of data into sound, so the human ear can notice patterns. Cabins, suits, tools, and atmospheres all change the answer. And if by the question you mean whether the universe is quieter than the movies suggest, absolutely yes. Much quieter. Almost offensively quieter. That is a wonderful thing to know, because it reminds us that reality does not need stage effects to inspire wonder. That silence is one of the things that makes space feel grand. It is not the silence of peace, exactly. It is the silence of scale. The silence of a place so thin and vast that even violence may unfold without a roar. A collision can blossom in light and debris with no thunder to honor it. A world can turn below you in perfect muteness. A star can burn with terrifying power, while the void between you and it remains utterly still. Its greatness is already there.